Hi, my name is Adu-Darko. I'm a delivery consultant here at Advizex, and today we're going to talk about introduction in networking in Kubernetes. We're going to talk about how pods communicate across the cluster, how containers communicate as well, and how pods communicate outside the cluster. Now let's start with how pods communicate with each other in the cluster. At the lowest level of every Kubernetes node is a software that is installed on it called the container runtime. We have the Docker engine and Containerd as the two famous container runtimes. These container runtimes are installed on these nodes so pods can run over there. These container runtimes also use container network interface plugins, usually called CNI plugins, that helps pods communicate across the nodes in the cluster. Some examples of the CNI plugins are Calico, Weave, and Flannel. In Kubernetes, the smallest unit is a pod and not a container. So a pod can be defined as an isolated virtual host having its own network namespace. Every pod in the Kubernetes cluster gets a unique cluster-wide IP address. So we don't need to explicitly create links between these pods in the node. The CNI plugins help do that. You can also define network policies that would allow or deny traffic to the pods, depending on the rules that you set in the network policies. You can have an application running on port 8080 across a number of pods, and since these pods have unique IP addresses, you wouldn't have any conflict running your application. Pods can contain one or more containers, depending on the use case. Some people can run a helper or a side application alongside its main application. For example, you can have a side application running database synchronization when you have a number of database pods inside your cluster. So now we can talk about how containers communicate inside a pod. Containers in a pod all run in a pod's network namespace. They communicate using localhost and a port. So let's say we have an application running on port 9010, it would communicate using localhost and 9010. However, to enable communication between different containers in different pods, we need the help of a CNI plugin, and this ensures communication between different containers in different pods. How do pods communicate outside the cluster? External traffic can get to your pods either via a load balancer or a node port or via an ingress service. Today we are going to talk about these things. What is a service? A service is basically a way to load balance your traffic to the pods. Let's say we have scaled this pod 3 times to create a grouping that we can call a service. We will name this service as service 1. What a service does is that it provides a way to load balance your traffic to any of these pods. It also provides a stable IP address and a DNS name, so when one pod dies and another pod is recreated, it does not lose its IP address. So when you create a service file, one basic thing that you have to define is a type. And we'll talk about 3 different types of Kubernetes service types. The first one is a cluster IP service type. This is the default service type, and it is used for internal networking. So let's say your traffic reaches out a cluster IP service. it's going to decide which pod and which port on the pod is going to forward the traffic to. It decides which pod using selectors, and a selector is basically a key value pair that is used to identify an object. It decides which port based on the target port that is defined in the service type in the cluster IP service. The next service type is a node port. A node port service type basically creates a service that is accessible on a fixed port on a worker node, so external traffic can have direct access to this fixed port. Let's say we have assigned public IP addresses of 159.1.1.1 and 159.1.1.2, 159.1.1.3 to these three nodes. What a node port does is that it creates a node port so that any traffic hitting this node port in this range, 30,000 to 32,767, will directly hit the port, and if it's hitting in any of these nodes, it will redirect the traffic to the service. The last thing that we're going to talk about is a load balancer service type. One thing that we should note is that with a node port service type, it is not secured because of the direct access to the fixed port on the node. With the load balancer, it is more secure than a node port, and the reason is because now the node port will be accessible to a cloud provider's load balancer. So any external traffic hitting this node port will first hit the cloud provider's load balancer and then would redirect the traffic to the service that has been exposed that way. The caveat is that with a load balancer, you can expose one service to one load balancer. So if you have multiple services, you would have to create multiple load balancers. Now we'll talk about an ingress service, which is not part of the service types. So external traffic coming in will first hit an ingress service, which will then direct the traffic based on the ingress rules, which are called ingress resources that are defined in the ingress service. So let's say we have another pod that has been scaled 3 times to create a service that we'll just name service B, or service 2. So depending on the rules or the ingress resources defined in the ingress service, it will forward the traffic to the service 1 or service 2. It can do this via 2 ways. It can do it via a path-based routing or a subdomain browsing. So let's say you have your domain, myapp.com, and you want to route traffic to your service 1. You can either do myapp.com/service1 or service1.myapp.com. So with an ingress service, you can define all your ingress resources or your ingress rules, and then you can route the traffic based on a path or a subdomain. So this is just a brief introduction to networking in Kubernetes, as it is a complex topic, but it is really essential for managing and deploying containerized applications.